Hello there. Welcome to the Trigonometry Review Appendix from Stevens's Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. So there's a few sections to this trigonometry review, and I'm going to do a little video for each one. So I'm going to do individual videos for each of these 6 parts, and then the problem set is just homework. So we are going to start here with triangle trigonometry. Alright, so I'm going to scroll down to that. Don't get dizzy. And I'm going to put it into full screen mode. Okay. So triangle trig, basically this is where you usually get started when you learn about trig, and it just defines the 3 main trigonometric functions, sine, cosine, and tangent, in terms of ratios of side lengths of a right triangle. So my right triangle is right here, and this is the right angle, and the theta that I'm taking the trig functions of is this angle right here. And you may remember the acronym Sohcahtoa, right? Sohcahtoa. And basically, that comes from the definitions of sine, cosine, and tangent. Specifically, the sine of this angle is the opposite over the hypotenuse. That's the so part. The cosine of this angle is the adjacent side over the hypotenuse. And that's the toa part comes from tangent, which is the opposite over the adjacent. It's just a ratio of side lengths. And from there, you define secant, cosecant, and cotangent as just the inverse of these primary 3 trig functions. And we don't go much into those, so I'm going to pass on that for right now. Again, this is meant to be just sort of a review and not necessarily a course in trigonometry. Okay, so there are some great things you can do with triangle trig, and specifically the Pythagorean theorem. For example, if you give me 2 side lengths, I can use Pythagorean's theorem to get the third, and it can be any 2 to get the third, right? So it's Pythagorean's theorem down there. And if you know the angle, theta, and one of the side lengths, it doesn't have to be h, it could be any of these side lengths, you can do some inverse trig and some identities, and you can get the other 2 side lengths and the other angle as well, right? But there are a few things you can't. Look, once you include the law of sines and the law of cosines, you can start playing around with non-right triangles. If you remember the law of sines and cosines, they're not particularly trivial to remember, but they're not so bad. And they're both derived by taking a non-right triangle and maybe breaking it up into 2 right triangles. There's a few things that you can't do with triangle, with trig defined entirely in terms of a triangle. For example, with this definition, my angle theta, this angle right here, it has to be bigger than 0, right? Bigger than 0. Otherwise, you don't have a triangle. You really have like a line, right? It has to be less than 90, because if this angle was 90 or more, right, then it would be over here. You'd never be able to hit this bar, and so you'd be over in this place, and your angle would be less than 90 again. So the point is, you don't really see it as a function of a continuous variable. It seems like this angle measurement has to go from 0 to 90. There's no reason to believe that you can. And by the way, the 90 is also, if we're using radians, which we'll get to in a couple videos, that's just pi over 2 radians, in case you're more familiar with that. So we need the angle to be between 0 and 90 in order to use triangle trig. And there's no reason to believe, when you look at this, that cosine, sine, and tangent are periodic functions, right? Which means, if you allow yourself to go beyond pi over 2 or beyond 90, these trigonometric functions repeat themselves, right? And that's a very important property of trigonometric functions, and that's not at all obvious whenever you think of trig just strictly in terms of right triangles. So the next phase would be to think of these trig functions in terms of the unit circle, but that will be the next video. And I will see you then. Bye.